In the previous lecture, we have discussed in detail the three-level ledger system. And today, our aim is to describe a four-level ledger system. As you know, a three-level ledger system is found in case of a Ruby ledger. But when you will study the helium-neon ledger, the ND-YAG ledger, then you will see that we need a four-level ledger system for achieving the population inversion. And apart from it, you have also seen there is a basic problem if you are talking about the three-level ledger system. Actually, what is the basic problem with three-level ledger system? I have told you earlier in the previous lecture. I am just repeating that thing here. And due to that reason, actually the four-level ledger system is required. You can see in this diagram, this is actually the three-level ledger system diagram. Here, you know that the atoms in the ground state are pumped to the third energy level marked by this line E3, and then these atoms suffer a fast non-radiative transition to the level 2, and this level 2, which is an excited level, is the metastable level, and the transition between level 2 and level 1, which is a ground level, is actually the ledger transition. So in this case, if you want to obtain the population inversion between level 2 and level 1, which are actually ledger levels, then at least 50% of the atoms from this ground level must be lifted to the third level to achieve the population inversion. And for this, that is to lift the 50% atoms from level 1 to level 3, we require a very high input pumping power. And this is the drawback of this three-level ledger system. It means a requirement of a very high power input of pumping system is actually the main drawback of this three-level ledger system. But when we will deal with the four-level ledger system, then you will see that actually the ledger transition takes place between two excited levels. Here the ledger transition takes place between an excited level E2 and the ground level E1. But in case of a four-level ledger system, which we will just discuss, you will see that the ledger transition takes place between two excited levels. And so in that very case, there is no need of a very high pumping power. And that's why the four-level ledger system is superior in use than the three-level ledger system. So this is the reason, or this is the problem with a three-level ledger system, and so we use in general the four-level ledger system. And as I have told you that in case of helium-neon ledger and ND-YAG ledger, you will find a four-level ledger system. So now let us start to deal with the four-level ledger system. You can see this figure. I have marked here the four energy levels marked by E1, E2, E3 and E4, as you can see. Okay. And in this four-level energy system, actually this level 1, which I have marked by E1, this is actually the ground level. Okay, this is ground level. And the levels marked by E2, E3 and E4, that is the levels 2, 3 and 4, these are actually the excited levels of the system. Okay. Now the atoms from this ground level 1 is pumped to the highest energy level, that is the fourth energy level E4. Okay. And when the atoms reached to the fourth energy level E4, those atoms actually make a fast non-radiative relaxation to the level 3. As I have mentioned it here, you can see that atoms in this fourth energy level make a non-radiative transition which is very fast, which is very rapid. It means the lifetime of the atoms in this fourth energy level is very small, and it quickly transit to the energy level E3. Okay. Actually, this third energy level is a laser energy level, or you can say meta-stable energy level. So the mean life of the atoms in this third energy level is relatively very large in comparison to the mean life of the atoms in the fourth energy level. Okay. And this E2 is also a laser level. Okay. This is also a laser level. And the laser transition, that is the stimulated emission of radiation, takes place between this E3 and E2, and as you can see, I have marked it by this arrowhead, and the laser light is emitted. Okay. So as I have told you that level 3, which corresponds to the upper laser level, is usually a meta-stable level, and it has a very long lifetime. Okay. And the transition from the level 3 to level 2 forms a laser transition. As you can see here, I have marked it. Okay. In fact, in order that the atoms do not accumulate in level 2, this level 2, and hence destroy the population inversion between 3 and 2, actually level 2 must have a very small lifetime. Okay. There should be an accumulation of atoms in level E3. This is a metastable level. But E2 should not be a metastable level, because in that condition, the population inversion between third and 2 level will be not achieved. So the atoms, when reach to this second energy level, it quickly transit to the ground level. As you can see, I have marked this by this arrowhead. Okay. And when these atoms reach to the ground level, again these atoms are pumped to the energy level 4. Okay. Now you can see, if the relaxation rate of the atoms from level 2 to level 1, level 2 to level 1 is faster than the rate of arrival of the atoms to level 2, then one can obtain population inversion between level 3 and level 2. Okay. And this can be achieved even for very small pump powers, as I have told you. This can be achieved by very small pumping power. This is its merit over the 3-level laser system. Okay. Now, the level 4 can be a collection of large number of levels or broad level. You can see, you have seen in the 3-level laser system too, that this highest energy level is actually an energy band. Okay. And so, if it is a collection of large number of levels or broad level or an energy band, in such a case, an optical pump source emitting over a broad range of frequencies can be used to pump atoms from level 1 to level 4 effectively. Okay. Now, apart from this, level 2 is required to be sufficiently above the ground level. This level 2 must be sufficiently above the ground level, so that at ordinary temperatures, level 2 is almost unpopulated. It means at ordinary temperature, you can say at room temperature, this level 2 has no atoms initially before the pumping. Okay. And the population of level 2 can be reduced by lowering the temperature of the system. Okay. So in nutshell, you can say that the atoms in ground level is pumped to the fourth energy level, which is just an energy band, and from this fourth level the atoms suffer a fast non-radiative transition. The mean life of atoms in this fourth level is very small, and this transition ends at the third energy level, which is actually a metastable energy level. This E3 is a metastable energy level, and the mean life of atoms in this level is very large in comparison to the fourth energy level. Okay, and these atoms in third energy level then suffer a laser transition to the level 2, and this level 2 is actually not a metastable state. So the atoms reaching to this level 2 quickly transit to the ground level, and again the pumping system raised the atoms from ground level to the fourth level, and this cycle actually maintains, and we get laser light due to the transition from level 3 to level 1. This actually gives the laser transition. Okay, I have marked this here, you can see. Now our aim is to write the rate equations for the different energy levels, and solving those equations you can find what should be the condition for achieving the population inversion for the transition between level 3 and level 2. So one by one we will write the rate equations for all these 4 energy levels. In fact, in nutshell, I have marked here all those things which I have just discussed. Okay. Now you have written rate equations various times before this lecture in 2-level laser system and 3-level laser system. So on the basis of the concept which we have developed in the previous lecture, we will write here the rate equations in brief. So let us see. I have actually assumed that in level 1 the population density is N1, you can see here. In level 2 it is N2, in level 3 it is N3, and in level 4 it is N4. These are actually the number of atoms present in these energy levels in unit volume. This is also called population density. Okay, so the rate of change of N4 it will be given by this equation. We have learned for writing the rate equations in the previous lecture. This will be given as dN4 by dt equal to Wp times N1 minus N4 minus T43 times N4. Actually, this Wp times N1, this is actually the number of atoms pumped per unit time per unit volume. It means the number of atoms which will be raised to the level 4 in unit time per unit volume. This quantity Wpn1 actually represents. Okay, and at the same time this Wp times N4, this is actually the stimulated emission per unit time per unit volume. So the number of atoms in fourth energy level is increased by this rate Wp into N1, and it is decreased by this rate Wp into N4. So the net rate of change of atoms in fourth energy level will due to this transition will be Wpn1 minus Wpn4. This Wpn1 is increment and Wpn4 is decrement. Okay. And apart from that, you know that the atoms in the fourth energy level also actually transit from fourth energy level to third energy level due to the radiative and the non-radiative transition. Okay, so if you consider that this T43 is the total relaxation rate, net relaxation rate from for the transition from 4 to 3, then this T4 3 into N4, this will also represent the number of decrease of atoms in fourth energy level per unit volume per second. Okay. So I have subtracted this value from the quantity Wp into N1 minus N4. Actually, as this T43 is the total relaxation rate, actually it consists of two terms. This is given as A43 plus S43. Actually, A43, you have seen in the previous lecture too, this is radiative transition rate, and S43 is non-radiative transition rate for the transition 4 to 3. Okay. Now, in the similar manner, you can write the rate equation for level 3. Okay. Actually, the rate equation for level 3 can be written as dN3 by dt equal to WL into N2 minus N3. Okay. Plus T43N4 minus T32N3. Actually, this WL represents the stimulated transition rate per atom between level 3 and 2. Okay. So WL times N2, this will actually represent the number of atoms increased per unit time per unit volume in level 2. Okay. And WLN3, this will represent the number of atoms decreased in level 3 per unit time per unit volume. Okay. And this WL, I have defined this in various times. WL is defined like this. This is C cube by 8 pi H nu cube times A32 GL of nu times IL. You know that this GL of nu is line shape function describing the transition 3 to 2. Okay. And IL is intensity of radiation which actually emitted when the transition takes place from this third energy level to second energy level, that is from E3 to E2. Okay. So the frequency of this radiation will be E3 minus E2 divided by H. Okay. E3 minus E2 divided by H. So the radiation whose frequency is this much, of that radiation, this IL is the intensity. Okay. Now again this T32 is equal to A32 plus S32. Actually A32 is the radiative power of this T32 and S32 is the non-radiative part of this T32. And T32 is what? This is net relaxation rate, as you have seen earlier, for the transition between 3 and 2. Okay. In fact, in the similar manner, you can write the rate equations for level 2 and level 1. And for level 2, you can write dN2 by dt equal to WL into N3 minus N2 plus T32 times N3 minus T21 N2. I hope you do not need any explanation of this equation because we have studied this several times. And this dN1 by dt, this will be Wp times N4 minus N1 plus T21 N2. Okay. Here again, this T21, this is the net relaxation rate for the transition 2 to 1, and this will have two parts. This A21 represents the radiative part of the of T21 and S21 represents the non-radiative part. Okay. Now, when STD state is achieved, then the number of atoms in these four energy level becomes constant and that becomes independent of time. So in STD state, these rates dN1 by dt, dN2 by dt, dN3 by dt and dN4 by dt all will be equal to 0. And at the same time, you know, the total number of atoms per unit volume of this system will be simply equal to N1 plus N2 plus N3 plus N4, and that will be a constant. Okay. So I have mentioned it here. You can see that total number of atoms per unit volume in this system is N1 plus N2 plus N3 plus N4. Okay. Now we will solve the above rate equations in STD state. So in STD state, when you say that dN4 by dt is equal to 0, then as you know, this equation 1 actually defines the value of dN4 by dt. See here, this equation 1. So if you will set dN4 by dt equal to 0 in STD state, you can find what will be the result. So let us put dN4 by dt equal to 0 in equation 1. So as you know, in equation 1 there was dN4 by dt equal to Wp into N1 minus N4 minus T43 N4, and that was equal to dN4 by dt. And now dN4 by dt is 0. So this will be equal to 0. Now arrange the term. You can see this will be N4 times Wp plus T43, and that is equal to Wp N1. So from here you can see that N4 by N1 is equal to Wp over Wp plus T43. Okay. Now you know that the transition from fourth level to third level, this transition is very fast. And as that transition is very fast, so you can say that this relaxation rate T43 must be much greater than this Wp. This Wp actually represents the transition rate from level 1 to 4. You can see. So this T43 should be much greater than Wp because the transition from fourth level to third level is very fast. So in this condition, this N4 will be much smaller than N1 because the number of atoms which is actually lifted from level 1 to 4 is at a slow rate. But the number of atoms which actually transits to level 3 takes place fastly. So in this condition, N4 will be much smaller than N1. Okay. So when you will use this condition, that is N4 is much smaller than N1, in all the above three equations, that is we will take dN2 by dt equal to 0. We will also take dN3 by dt equal to 0. Okay. We will also take dN1 by dt equal to 0. Okay. All these equations have been defined earlier. And then we will impose the condition N4 much smaller than N1. I have not done the algebra. You can see after imposing this very condition on all these three equations, we will get a simple result. And I have mentioned this result directly and you should remember it. You can do it because I have not done this algebra. This is just a homework for you. So you can see this N3 minus N2 divided by N will be equal to this much. Okay. This is Wp times T2 minus T21 minus T32 over Wp times T21 plus T32 plus T32 times T21 plus Wl times 2Wp plus T21. Okay. Now, you know, if there will be a population inversion between the third energy level and the second energy level, then N3 should be greater than N2. Okay. And in this condition, N3 minus N2 will be greater than 0, that is positive. And for this, you can see this equation number 11, that this will be positive only when T21 minus T31 will be positive. And for this, T21 should be greater than T32. Okay, only then population inversion will be achieved. So definitely for achieving the population inversion, this condition must be satisfied. Okay. Now, when you say that T21 is greater than T32, it means the spontaneous rate of de-excitation of level 2 to level 1 must be larger than the spontaneous rate of de-excitation of level 3 to level 2. So now this equation number 11, when it will be simplified, we will get approximately a very simple result. In fact, in an approximation, you can see that this will be written as N3 minus N2. Sorry, the page has been turned. This is just a defect of my device. This will be removed shortly, but it occasionally takes place. So now see here. N3 minus N2 divided by N is almost equal to WP over WP plus T32 and times 1 over 1 plus WL times T21 plus 2WP over T21 times WP plus T32. Okay, and from this equation you can clearly see that this pumping rate WP for achieving the population inversion between third level and level 2 is very small. This WP is the pumping rate and this is very small. Okay, but you have seen that in case of the 3-level laser system, this pumping rate WP is not very small, it is very high. This was the demerit of 3-level system, but in case of 4-level system, that a very small pump rate WP also achieved the population inversion. It means when WP is even very small, even then N3 minus N2 will be positive and we get a population inversion between the third level and the second level. But this is just a contrary what we have found in the 3-level system, where there was actually a minimum pump rate, okay, to achieve the population inversion. It means by applying any pump rate, you cannot achieve population inversion in case of the 3-level laser system. But here you can see that even when WP tends to 0, even that, then you can achieve a population inversion between the third level and the second level. This is the merit of this 4-level laser system. Okay. Now, just below the laser oscillation, this WL is equal to 0. And if you consider here this WL equal to 0, you can see the term inside this square bracket will be simply equal to 1. Okay, and in that condition, this N3 minus N2 divided by N, which I have written here delta N by N, this will be simply equal to WP by WP plus T32. Okay, and this delta N, which is N3 minus N2, this is just the population inversion density. It means how much number of atoms in level 3 is greater in unit volume with respect to the second level. You can calculate from this result during the laser oscillation when WL is just equal to 0. So you have seen that after writing the rate equation for the 4 levels of a 4-level laser system, you can clearly say that there may be a population inversion between the 2 excited levels, that is third level and second level, even when the pump rate is very small. So this 4-level laser system is in 4-level laser system, it is very easy to achieve the population inversion in comparison to the 3rd-level laser system. And as I have told you that this 4-level laser system will be utilized in case of 2 very important laser systems. The first one is helium neon laser and the second is ND arc laser. and we will discuss these laser system in very detail in the forthcoming lectures.